All right, so this is problem number 3 from FRQ Friday number 8 in AB Calc. And again, not going to read through the problem. We're just going to jump into part A. Part A wants us to come up with an equation for the line tangent to the graph of G at x equals 1. What we know about G is that G is equal to e to the f of x. So if I want to find an equation of a tangent line, I need a slope and I need a point. So what I know right now is that x equals 1. I don't know what y equals, and I don't know what my slope is. So to find my y coordinate, y would be g of 1. So that would be e to the f of 1. So to find f of 1 they told me right here is 2. So that makes my y coordinate e to the 2. So e squared is my y coordinate there, or a decimal value of 7.389, since you were able to use a calculator on this. Then to get my slope is going to come from the derivative, so from g prime. So to find g prime, I have to take the derivative of this equation for g of x. So that is an e to the u function. So remember, e is its own derivative, but then we have to multiply by the derivative of the exponent. The derivative of f of x is f prime of x. So this is your expression to find g prime of x. So then to find our slope, we're going to find g prime of 1. So that becomes e to the f of 1 times f prime of 1. Well, we already figured out before that e to the f of 1 is e squared. To find f prime of 1, the graph of f prime is given at the top, and if you go to where x is 1, there's your function value. So that's times -4. So my slope is -4e squared. The decimal value for that was -29.556. Then once you have all that information, it's just a matter of writing it as a tangent line equation, like that. So where do your points come from for this problem? Well, this part was worth 3 points. You got 1 point for an expression for g prime of x, 1 point collectively for finding the y value and the slope, and then 1 point for writing the equation of the tangent line. So that's a total of 3 points for part A. Then for part B, they wanted you to stay within the open interval from -1.2 to 3.2. Find all values of x for which g has a local maximum. So again, we're going to be working with the derivative. Maximums are going to occur where the derivative equals 0 or does not exist. And in order to be a max, we need g prime to change from positive to negative. So g prime of x from part A is e to the f of x times f prime of x. Well, e to the anything is always going to be positive. So this part doesn't really matter because it's always positive. So the only thing that could really affect the outcome for the value of g prime of x is f prime of x. So we're looking for where is f prime of x changing from positive to negative, because that would cause g prime of x to change from positive to negative. So if you look at the graph of f prime up here, it is changing from positive to negative at x equals -1. So you would say that there is a max at x equals -1 because f prime of x changes from positive to negative here. And you would need to say that that causes g prime of x to do so as well. So you got 1 point for identifying that it would be at x equals -1, and then you got 1 point for the justification for y. You did actually have to write words as part of your justification. All right, part C gave us an equation for the second derivative, so they didn't make you go through yourself trying to figure out what the notation would be. And they said, is G double prime of negative 1 positive, negative, or 0? So that's really just a matter of thinking through what that value would turn into. So using the expression that they gave us, that would be e to the f of negative 1 times f prime of negative 1 squared plus f double prime of negative 1. And then it's just a matter of doing the math. Well, e to the f of negative 1, we don't know exactly what that is because we don't know f of negative 1, but we know that it would be positive. Okay? And then that's going to get multiplied by the stuff in the brackets. So really we just need to focus on what's in the brackets as to whether it would be a positive or a negative value. So f prime of negative 1, we can see on the graph of f prime, when x is negative 1, this has a value of 0. So this is 0 squared. And then f double prime of negative 1, we don't know exactly what it is, but it would be the slope here. I can tell that that is a negative number. So I have a positive times 0 plus a negative. So that would be a positive times a negative, which is a negative number. So your G double prime of negative 1 would be negative. Now, for your justification, you can't really just have the work that I've done there. You would basically boil it down to this right here. Because f prime of x is decreasing at x equals negative 1, f double prime of x would be less than 0, causing G double prime of negative 1 to be less than 0 also. You couldn't just write that, though, without showing the justification for how f double prime of negative 1 really is the decision maker in this part of the problem. All right, so C was worth 2 points. You got 1 point for saying that it would be negative and 1 point for explaining why it would be negative. And then D. D wants the average rate of change. This is way, way back. Like, this is just good old middle school slope. This is how we began rate of change before we knew anything about derivatives. So if they want the average rate of change of G prime over the interval from 1 to 3, that means they're looking for G prime of 3 minus G prime of 1 over 3 minus 1. So that means we have to actually find values for G prime of 3 and G prime of 1. Now, this takes you then all the way back to part A, where really if you didn't come up with the equation for G prime of x correctly in part A, that messed you up on A, B, and D. C, you could make it through, but the other two, you would just be messed up. So if I want G prime of 3, G prime of 3 would be e to the f of 3 times f prime of 3 minus, and then for G prime of 1, it would be e to the f of 1 times f prime of 1 all over 3 minus 1, like that. Okay, so e to the f of 3 times f prime of 3. Well, f prime of 3 is 0. So you might have thought you were stumped with the e to the f of 3 because we didn't know what f of 3 was. But f prime of 3 is 0, which makes this whole first term in the numerator 0. And then the e to the f of 1 times f prime of 1, if you found it correctly in part A, that was negative 4e squared. And then all over 3 minus 1 is 2. So you end up with 4e squared over 2, or 2e squared for your average rate of change. So you got this part of the problem was worth 2 points. You got 1 point for knowing that you needed to do average rate of change. So even just writing this would get you a point. And then you got a point for your final answer. Okay, so that's your 9 points total, and that's problem number 3.